Alright, let's continue the freefall lifeboat case on the free surface. At this stage, we want to generate the meshes we need for the problem. So, under Operations, right-click the folder and choose New. From the menu that opens, choose Mesh and then Automated Mesh. In the Automated Mesh dialog, select the background mesh first. Do not click OK yet. Let me move this window down a little. Then we can review the options in this panel together. The first section asks whether we want a surface mesh. Yes, enable surface remesher so the surfaces follow the chosen size. Then it asks whether the surfaces should also be repaired automatically. For the background region, the answer is no, because all my surfaces are simple. They are planar surfaces, so the mesh is generated easily on them. I also do not need geometric sensitivity here, so I leave those options off. Now we choose the core volume mesher for the volume cells. I will use the trimmed cell mesher for the volume mesh. When I select trimmed cell, it asks whether I want prism layers. For this mesh, the answer is no. If you remember, we defined all the boundaries earlier. Those boundaries were chosen so that boundary layers are not needed here. 3 of the boundaries are velocity inlets, 1 is an outlet, and 1 side is symmetry. So there is nowhere in this background region where I need prism layers. Therefore, I leave prism layer off, click OK, and create the first mesh operation. This first operation belongs to the background region. Then I press F2 on the keyboard to rename it. I rename it to background mesh. That way I know this is the mesh operation for the background. Now I want to create the mesh operation for the overset region. I could repeat the same path, but there is an easier way. I can copy the background mesh operation with right-click and paste, or Ctrl+V. As you can see, the operation is copied, and now I just need to rename it to overset mesh. Then I need to change its input, because the previous input was the background. So I replace that input and select the overset part as the new input. That means this operation now meshes the overset, and the other one meshes the background. At this point, both of our mesh operations are ready. Now we have created the operations we need, but let me explain a few points. We should think carefully about the overset region and the background region together. The first point is about where we want the highest accuracy in the solution. That highest accuracy zone is the region we call the overset region. This is the zone where we want the finest mesh and the best resolution. That is why we define a separate overset region and make its cells very fine. If we had no mesh limitation, we would not need overset at all. We could simply mesh the whole domain very finely everywhere. That would be the simplest approach in theory. But for practical problems, that mesh becomes far too heavy. The computational cost rises a lot, and many industrial cases become impractical. So we use overset to avoid that cost. Overset lets us keep a very fine mesh around the important physics. Here, that important zone is around the boat and its motion. Then, Across the boundary between the overset and the background, we exchange the data. There, we solve the rest of the physics with a lower cost. There is one very important point about that interface between the two regions. The cell sizes near the interface must be close to each other. In other words, the mesh size and the cell order on both sides should be similar. For example, suppose the overset cells are about 1 millimeter. If the background cells jump straight to 5 millimeters, that jump from 1 to 5 creates a very large change in cell size. Then the aspect ratio between neighboring cells becomes too large. That makes the gradients inaccurate and the data transfer poor. A large part of the physics can be lost there. Then that inaccuracy is passed into the main solution around the hull. In many cases, it can even cause instability or make the solution crash. That was the first point I wanted to mention. The second point is about how you think about the case as a CFD engineer. When I build the overset mesh, I need to think about where the highest gradients appear. This is an unsteady freefall case. I release the lifeboat from a height with some initial speed. Then it comes down and reaches the water surface. At the moment the boat interacts with the air-water interface, the gradients become largest. Ideally, when I build the overset mesh, I want one thing. I want the overset mesh aligned with the interface mesh. That alignment helps the gradients be resolved more accurately when the boat reaches the interface. So first I align the overset mesh with the background mesh. Then I move the boat into the position from which it will fall. That is the second point we should keep in mind for this case. The third point is also important. Around the hull, the mesh must be very fine. That fine mesh is needed to capture the physics correctly. Then, as we move away from the hull and toward the interface, the cells can grow. At the interface boundary, the mesh sizes should match the background mesh. Farther away, we can continue to coarsen the mesh toward the far boundaries. In the previous examples, we saw that multi-stage meshing needs refinement boxes. Inside those refinement boxes, we apply volume or surface controls. That is how we guide the mesh and generate better cells. So here I need to create several blocks for that purpose. To do that, right-click Parts, choose New Shape Part, and then Block. In the window that opens, I enter the coordinates for corner 1. For corner 1, x is -28, y is 0, and z is -45. For corner 2, x is 5, y is 12, and z is 0. This block covers the region where the free fall happens. It also covers the area where we want to capture the interface. I click Create, and then Close, and the first block appears. Now I rename this first block to Overlap. Now I want to create another block so I can refine the interface itself. I follow the same procedure again. This time I enter the coordinates for corner 1 x -125, Y0, and Z-34. Then for corner 2, X is 125 and Y is 50, and Z is -24. Then I click Create and Close. This is the second block. Now I rename this block. I call it Water Surface. That tells me this is the block that contains the interface. Now compare this with the overlap block. The overlap block is meant for the boat freefall region and its impact with the interface. So that region is refined, and now I can also create another block. Next, I create another block to refine the mesh around the boat itself. And Z-4. Then I enter the second corner coordinates. For the second corner, X is 4, Y is 5, and Z is 8. As you can see, this block covers the region around the boat. Then I click Create and Close. This last block focuses directly on the boat itself. That focuses on the boat itself, so I rename it to Boat Block. So now we have created 3 different blocks. The first block is the one that refines the main region around the boat motion. As I said, we need a finer mesh there. The overlap block is the one that refines the free fall path of the boat. It also covers the impact zone near the interface. And the third block is used to refine the interface region itself. You can also look at the depth of these blocks. You can see that the interface block covers the full interface across the Y direction. For the overlap block, only the nearby region is important. Once we move farther away from the boat, we do not need such a fine mesh anymore. Now, at this stage, we want to apply the dimensions and mesh sizes. We apply those settings to the mesh operations before moving on. Before that, let me first build an intuition for the sizes we are using. From the top toolbar, select the ruler tool. I think it did not select correctly, so let me choose the ruler once more. As you can see, the length here is about 245. That is roughly 245. And in the Y direction, the width is about 50. So the overall domain is about 250 by 50. A reasonable basic size for the background mesh is one that keeps the total cell count under control. For that reason, I go to Background Mesh and open Default Controls. And I change the base size from 1 meter to 5 meters. That means I will have roughly 50 cells along this direction. After applying the base size, we can add the custom controls. For a custom control, right-click and choose New. Then, in the menu that opens, choose Volumetric Control. Click that option. I renamed this new control to Overlap because it will refine the overlap region. This control is meant to refine the overlap zone. Now open the Overlap Custom control. As you can see, there is a surface remesher section here. Enable its customization. Once you enable customization, the Values section becomes active, and you can set a custom size. As you can see in the Properties window, the first question is the size type. I can define the size as relative to base or as absolute. Relative means a percentage of the base size. If you remember, our base size is 5 meters. I change it from relative to base to absolute. Then I enter 1.25 as the size. As you can see, when I enter 1.25, the software calculates the corresponding percentage automatically. If I switch back to relative to base, I can express the same size as a percentage. The absolute size becomes 2.5 meters, but if I use 25%, it becomes 1.25 meters. So it does not matter which option you use, as long as the final size is the same. We choose this size for a very specific reason. Because it is very important that the mesh in the Overset region has a similar cell size when it transfers into the background region. If you remember, we designed the overlap region so that when the boat is inside that zone, the background mesh there is fine enough. To make the transition between overset and background smooth. Outside this overlap zone, the background mesh is much coarser, about 5 meters. So I apply this custom volumetric control to the background mesh. That way I make sure the background mesh in this region has a 1.25 meter size. Up to now, we have only activated the surface remesher. So this size is applied only on the surfaces, not in the core volume. To apply the same custom size inside the volume, I need one more step. I must choose how to customize the trim cell settings. For this example, as I said, we need the core volume cells to be roughly aligned and similar in size between the overset and the background. So I choose isotropic customization. When I activate that, I am telling the software to read the custom size from the values folder and apply it to the trimmed volume mesh in the overlap region. That means all the cells in this overlap zone will follow that custom size. The same applies to the surfaces in this zone, including the symmetry surface. Another refinement that we need to apply is for the region where we model the interface. If you remember, we defined a block called water surface. We said this block is where the interface will pass through. So we created a band above and below the expected interface location by using a block around that interface zone. Now I go back to the background mesh. Under Custom Controls, I right-click again and choose New Volumetric Control. Then I create it. Now we need to name this new control. I press F2 to rename it. I call it Water Surface. This will be the water surface control. If I open it now, you can see that I can decide whether to activate surface remesher. First, I activate the surface remesher section. For the custom size here, I do not really need to change the surface size much, so I keep it as relative to base. That means the surface size will stay unchanged in this region. Then I click the Trim Cell option under Controls. Here I can choose isotropic or anisotropic refinement. Isotropic would refine the volume mesh equally in all three directions. But I can also refine only in the direction with the strongest gradient. In this example, the strongest gradient is normal to the surface, which means along the z direction. So I choose the anisotropic option. As you can see, a new item appears in the Values folder called Trimmed Cell Anisotropic Sizes. Then I enable editing for all three directions. Now, when I expand the folder, it changes from a single value to separate directional values. So it becomes a folder with subentries for each direction. Let me enlarge the window a little so it is easier to see. Now I click on the X, Y, and Z entries. You will notice that they all initially inherit the same value as the surface settings. So for X and Y, I leave them unchanged at 100% of the base size. But for Z, I set it to 50% of the base size. For this custom control, the key point is this. Inside this block, along Z normal to the interface, the cells will be refined. The cells will be cut in half. So instead of 5-meter cells, I will have 2.5-meter cells in Z. Now the two custom controls we needed for the background mesh are ready. We have applied their settings, and now we can go to the background default controls. There, look for an option called Mesh Alignment. As you can see, this category does not appear in the default controls yet. But if I click on Trim Cell, there is an option called Perform Mesh Alignment. When I turn that on, Mesh Alignment becomes available. Then I can go back into the default settings and define the location or reference point for the alignment. In other words, I can specify the point relative to which the cells are aligned. When I apply it, you can see that this is the point that I use to align the background mesh cells. So all the background cells are aligned based on that point. Another thing that I forgot to mention is this. If you look at the custom controls now, both of their icons are faded. That faded color means the controls are inactive. Even though we set all the parameters, they still have no effect yet. Now, if we inspect the Properties window carefully, the issue becomes clear. We can see that the control itself has been enabled. But we forgot to tell the software where this control should be applied. That is exactly why we created those blocks earlier. Now let us activate this control properly. I select the overlap block and click OK. As soon as I assign a region to the control, the icon color changes. It becomes solid, which means the control is now active. I do the same for water surface. You can see that no part is selected yet. so I click the Part button on the right. Then I choose the water surface block and click OK. The color changes, and the selected block is highlighted. Now, whenever you click on a control, the block where it is applied will be highlighted. If you select both of them, you can clearly see where you applied the customizations. Another thing we can do for the background mesh is change the growth rate away from these refinement boxes. We have two parameters for that: surface growth rate and volume growth rate. These parameters tell the software how fast the mesh should grow from a refined zone. Back to the base size. That growth can be applied in the volume or on the surfaces. By default, the surface growth rate changes with about a factor of 1.3. I change it and set it to slow. I do the same for the volume growth rate. I also set that one to slow. With these growth rate settings, I can control how fast the nearby surface cells change. I set that one to slow as well. This setting makes the transition from the 1.25 meter zone much smoother. The transition to larger cells will not happen instantly. Instead, it will happen over 2, 3, or even 4 steps. That helps the high velocity and pressure gradients be solved more accurately. So this gives us a better and more accurate solution. At this point, we have fully defined the background mesh and its settings. Now let us move on to the overset mesh. Let me zoom in a little. I can also change the view to -Y with Z pointing upward. That way I can see the boat more clearly. Now I select the ruler tool from the top options. I pick two simple points here just to estimate the overall size. As you can see, the boat is roughly 13 to 14 meters long. So when I create its mesh, I need to respect those dimensions. In overset mesh, under default controls, the base size is 1 meter, and I keep it that way. This 1 meter value is the overset base size. As we move away from the boat, the mesh can gradually become coarser. The cells can become coarser, but near the interface, the overset base size is what matters. So near that region, I have cells of about 1 meter. Then, when I move into the background mesh, we already set that region to 1.25 meters. So the change in cell size between overset and background is only by a factor of 1.25. That is a very reasonable ratio for increasing cell size. That is exactly what I meant by a smooth transition between cells. Now right-click on Custom Controls, choose New, and create a new volumetric control. Name it Boat, because we want to refine the area around the boat. Then go to Parts, select the boat block, and click OK. With this control, at this stage, we only want to refine the surface mesh around the boat. So, under Controls, enable Surface Remesher Custom Size. Then, in Values, set the custom size to relative to base and choose 50%. That means we do not refine too aggressively at first. We only make the mesh a little finer for the first run. Then we can look at the solution results. And if we want, we can refine it again later. I could also turn on the trimmed cell option and refine the volume around the boat more. But for this tutorial example, I prefer to keep it lighter. Of course, you can activate isotropic refinement and apply the same base size if you want. One reason I do not activate trim cell here is this. Remember that the overset base size we chose was already 1 meter. If I refine that further, the mesh quickly becomes much heavier. That is because the trim cells would usually refine in 2 or 3 directions. So the total cell count grows a lot, and the mesh becomes very heavy. For this stage, it is enough to refine only the boat surface with surface remesher. With these changes, I have now used all 3 blocks for mesh customization. So up to this point, I think the mesh settings are sufficient for this example. Later, if needed, we can come back and make the mesh finer. Now what we do is either click Generate Mesh at the top, or right-click each mesh operation here, and choose Execute. After the background mesh is generated, right-click the Overset Mesh operation, and choose Execute, so the overset mesh is generated as well. Once the mesh generation is complete, we can create a mesh scene. Click the Scene Creation button at the top and choose Mesh. Then a mesh scene is created, and I can inspect the result. I can change the view again to angle Y- with Z pointing upward. Now this is the final mesh we created together. As you remember, we said the blocks would be used to refine specific zones. For example, you can see that around the water surface block, the mesh is finer. Let me mention one point here. In a real practical case, you would usually need a much finer mesh to capture the interface. You would usually need a much finer mesh than this. But for this tutorial, let us keep this mesh for now. We also defined the overlap zone and said the mesh should be refined there. As you can see, the mesh in that region is indeed finer. We also told the software that when it moves out of the overlap zone toward the base size, it should do that very slowly. And as you can see, the transition from the fine mesh to the coarse mesh toward the 5-meter base size happens smoothly and gradually. That helps when we compute the gradients across these regions. It ensures there are enough cells between one size change and the next, so the jump in cell size does not become too severe. So, in this exercise, we have successfully generated the mesh we need. In the next stage, we need to move the boat into its proper position and continue by initializing the solution and setting the boundary conditions. Thanks for staying with me up to this point in the video.